Okay, good afternoon. So after Michael's comment, I'm feeling like, $100 billion plus revenue, is small company these days. Anyways. But yes, HPC is a small part of that, but a growing part of that. So I wanted to spend, for my 15 minutes of fame, just do a quick update. The timer is going down. It doesn't even look like it's 15. From a couple of the comments yesterday, I wanted, in typical fashion, putting my slides together during the day yesterday so I could present them today. I grabbed this one out of our generic collection of slides, really because there was a couple of comments that were really talking about how the workloads drive the definition of the systems, and that really resonated with me, partially because that's very much the way that we're really driving our focus. We're really looking at the industries and application areas where we're focusing our HPC efforts and looking at what are the issues that customers are telling us are the ones that we need to focus on for our systems. I've said multiple times over the last few years that, that a few years ago, if you took an RFP for an HPC system, you could distill down the 200 pages down to, I need this amount of performance and I have this amount of money to spend. And in the last, few years, that has increasingly become, I need this amount of performance, I have this amount of money to spend, but oh, by the way, I only have power for this amount, or I only have space for this amount, and so on, and how do I fit all of that into that? And so, we're obviously, this is high-performance computing. We are focused on delivering performance in our systems, designing industry standard servers, but doing that with an eye towards the features necessary to deliver HPC performance, including things like integrating accelerators, integrating highest performance interconnects, and so on. Increasingly, we're focused on efficiency, power efficiency, space efficiency, and so on, and we'll talk a little more about that. And lastly, and it relates to a little bit of the question of the the knowledgeable versus the non-knowledgeable, is really accessibility to HPC resources across the board, whether that means a focus on how we can sell simple, easy-to-use, package solutions into the small and medium manufacturing business, a focus that my team is driving. How we can work across the HP Cloud organization to provide HPC cycles via the cloud, and we're doing that with the team that is referred to as HP Helion, once again proving our skill in product naming. That's a common theme that I have. And so on. So really, again, trying to make it all a lot simpler. We do that, of course, bringing together all the pieces into a complete solution. Obviously, we focus on industry standard servers. That's what my team is specifically focused on. But also looking at storage and big data solutions. That's very much of a corporate-wide initiative. We're a very strong focus around the integration of it with accelerators. Again, high-performance networking, cluster and general systems management. Again, a big focus on power and cooling. Increasingly a focus on the services aspect of HPC. For a long period of time, we didn't get a lot of people asking us about outsourced services, managed services, and so on. A lot of that was happening. Some of the people in the room use our services for various parts of our organization. But just in the last few months, we've had a number of customers, some very traditional HPC customers, coming to us and saying, we want to do our next big system, but we don't want to manage it. We're not even sure we want it in our facilities. We want it dedicated to us. And in some instances, we don't want to pay for it in the usual way. We want to pay for performance. And so lots of different sort of services models for how they want to acquire a system. And of course, cloud is a piece of that. But as I've talked to this group a number of times, I think I've pointed to the fact that over time we've been more and more focusing on this notion of really designing systems more and more specifically for specific workloads. And so, I commented that for HPC a moment ago, but we're really looking at that across the board with our server product line. So this is a slide that was used first time just a couple of months ago by the HP Servers organization, really looking at how we take the broad portfolio of servers and start looking at how we align them with different parts of the overall IT industry. And oh, by the way, our organization is then structured that way. So we have a group that is called Core Servers, and they're the ones who are, among other things, building our traditional rack-level servers, the 1U pizza boxes, 2U systems, and so on. And oh, by the way, we still sell a lot of those into HPC. In the bottom right-hand corner is the Blades organization, really focused on more enterprise computing, specifically around virtualized environments. In the upper right-hand corner is kind of the very traditional mission-critical world, which is, you know, historically in HP, the Superdome world and so on, which is, you know, boldly moving into the x86 world, with a new system that'll be coming out a little bit later this year called Dragonhawk, which is, think of Superdome, but take out all the Itaniums and plug in Xeons. So an x86 mission-critical big SMP architecture. But then we have an organization that I'm part of that used to be called Hyperscale. We're currently using a cryptic name, density-optimized / service provider / HPC. We prefer to just say Hyperscale. That's really focused on big data, HPC, and the web / cloud / service provider market. And all those are together because they have a common theme of large-scale, scale-out solutions. And we're building specialized servers just for that market. The SL series, that's been our bread and butter in HPC for the last few years. Some of the biggest systems that we have, the Tokyo Tech system, which is our largest system on the top 500, is based on that architecture. We've done a lot of work there, again, to integrate accelerators as one of the earliest systems with integrated GPUs and so on. You heard a little bit about Moonshot yesterday by Gerald and the guys from PayPal, who did a terrific presentation. And I want to say a little bit more about HP Apollo, which is our latest. So this is a blow-up of that broader product line. I wanted to just highlight a couple of things on here. One is, in the bottom middle there is storage density. The SL4500 series is a storage server, something that we designed specifically for scale-out storage applications. Things like Scality, things like Red Hat Storage, things like Hadoop. All focus on that. Those things are, you know, as is the theme of the growth in big data, we can't build those things fast enough. As I mentioned, the SL6500 has been our bread and butter. It was interesting hearing about some of the advances from some of our other friends in the market. One piece that's been very successful with that particular product is we've been selling an 8 GPU system since 2009. Based on that architecture that is very heavily used in the oil and gas market. There's a 3 GPU version, and when I say GPU, I should, in light of my co-sponsor here, say it's really accelerator, so we have GPUs there, as well as Intel Xeon Phi. But then just recently, we launched the Apollo 6000 and 8000. The 6000 is a new air-cooled system, but designed at rack scale. And by rack scale, we mean these are going to be deployed by the rack load. So if you're deploying them by the rack load, you start asking the questions of how can we drive the power efficiency. The way that we've done it here is we've taken all the power supplies out of the chassis and put them into individual power shells that then delivers DC power to the servers in the rack. So we have a small number of very large, very efficient power supplies delivering power to the whole rack. And oh, by the way, we manage it all at the rack level in terms of managing power, doing power capping at the rack level, and so on. So traditional air-cooled cluster infrastructure, but really pushing on density and power efficiency, which are very related to one another. But then the big news was the Apollo 8000. And we talked about it last time. I think I showed the video of Steve Hammond, and you're going to get the live Steve Hammond in a little while. But this is an Apollo 8000 server tray. A little light, but And basically, this is a liquid-cooled server with not a single pipe connected to it. Not a drop of water flows into the server. Not a drop of liquid flows into the server, but yet is liquid-cooled. Heat exchange occurs on what's referred to as a thermal bus bar, which is this edge of the server, gets pressed against what's called the water wall, which is a metal fitting on the other side of which is warm water. Heat is transferred across that mechanical connection. What that means is to service this system is roughly equivalent to servicing a blade. There's a little latch up here that you unlatch that breaks that mechanical connection, you slide it out. You want to put another one back in, you slide it back in exactly the same way. The heat inside of this moves through heat pipes that you can just barely see over here that brings the heat off the processors over to the thermal bus bar. By doing this, we're enabling an environment that provides the benefits of warm water cooling, but with none of the disadvantages. We eliminate all the safety concerns because all of the water is independent of the IT, plus all of the water flows and so on are done in such a way to maximize safety. There's all sorts of sensors. There's actually multiple water loops so that we can protect the environment and so on. And again, that is the solution that is available now. It is running at NREL, and I think Steve will talk about it in a little bit more in a little while. So with that, I'll close. Again, making the point that with the latest line of products, again, focusing on how do we deliver performance with a standard server infrastructure, with the use of accelerators, with the use of high-performance networking, doing it with maximum power efficiency, maximum density. With this sucker, we put 144 servers in a rack, okay, getting incredible performance density. And again, finally, in this notion of unleashing HPC by simply making more available across the market. So with that, I thank you. And I think I may have time for a question.
Any questions to Ed?
Yeah.
What do you see as the lowest hanging fruit, or some of them verticals, for ARM, for your moonshot?
Getting back to the moonshot question, I thought the discussion with PayPal was right on yesterday because, and I think I've been spending a lot of time with the moonshot team trying to think about where moonshot fits into HPC, and the conclusion that I think we've had is our customers will tell us, which is exactly what happened with PayPal. I thought that the whole dialogue with Gerald Klein, having given them a presentation on moonshot, and him about saying, "Oh, you won't be interested in this DSP thing," and then Ryan coming back and saying, "Hold on," was exactly what we see is happening. We're seeing folks trying it out, and that's really I think the exciting thing is that there's a lot of very interesting variations there. The TI technology that provides the ARM cores plus DSPs. There's ARM cores plus GPUs. There's ARM cores plus FPGAs. There's a variety of different specific configurations that are being done there. And people are trying them out. And I think what we're going to see is a whole new set of applications that people will discover work well in these new environments. It's not the sort of traditional HPC applications that we've all know and love, but rather some of the new things. And I think that's really exciting. And of course, ARM64 is going to have an impact that we already have a number of our, if you will, traditional HPC customers who've been testing those out. So very early in the development of that technology, and it's really, I think, going to be our customers who tell us where it should be used.
Hey, Ed. So first off, it's absolutely great to see HP doing some cool stuff in liquid cooling, and a lot of the larger vendors now looking at liquid cooling as a real way forwards. You say there's no liquids in the servers, but what about in the heat pipes?
Yeah, so if you're familiar with heat pipe technology, that's actually been around for a long time. And when I say, I didn't say no liquid so much as no liquid flow into it. The heat pipes actually does have a tiny amount of a glycol-based liquid. It's literally a couple of drops. And it's in there under negative pressure. So basically what happens, if one of those pipes were to break, that couple of drops of liquid instantly evaporates. So it is zero potential damage. It's no different. If you open up your laptop, you'll see basically the same technology. The key, again, point is that there's no liquid connections. There's no flow from the outside in. There's no water flow. There's no, whatever liquid flowing in or out of the server. It's just heat that's coming in and out of the server. Yeah, was there another question back there?
Oh. Hey, Ed. I was deciding whether to ask the question or not, but Michael, I thought I had a comment that was spot on about HPC companies are really small companies within big companies. And having run a small company that was a pretty big friggin' company inside of a humongous company, you're in the exact same boat. I think that the other comment that Michael made about that there really is not enough margin left over for innovation is absolutely critical to everybody who sits here who can't understand why we can't deliver exactly what's needed to be delivered to the HPC community. Is there, if you were going to give some guidance in terms of the best thing that the HPC community can do to help itself in terms of getting moved further up the roadmap prioritization list within companies like HP or Dell or whatever else, would there be any guidance?
Well, that's a great question. We're always caught, in a sense, between a set of folks who are using as their model for HPC solutions the cheapest, least expensive, most white box-like solution with no innovation, and thinking in those terms, and then looking at something like what I just showed you that has a lot of our innovation in it. And if you start making those equivalent, you've got a fundamental disconnect. I think the key at the end of the day is, and this is a challenge for us as much as it's an issue for our customers, is sort of understanding how we value that innovation. And in a sense, developing a willingness to be able to pay for some of that innovation, at a reasonable price. If it's the classic thing. No one's going to spend the same amount of money for a Ferrari as they're going to spend for a Volkswagen. Not that some of the Volkswagens aren't cool, but again, there has to be a willingness to sort of invest in some of that. There's another side that I actually thought you were going on as you were asking the question, which is the question that I always get, which is, is HPC in fact profitable? And how important is it for a much larger company like HP? And we had the interesting experience some months back. We were asking Meg Whitman, our CEO, for more money to invest in some of the things that we were doing with these products. And as part of that dialogue, we gave the traditional, here's the financials for the last year kind of things. And in the middle of that meeting, she just sort of went down and started squinting at the slide because in the bottom right-hand corner of the slide was the punchline, which is the margin that we delivered back to the company. And understand that as the CEO, the only HPC deals she ever sees are the really ugly ones, right? That get escalated all the way up to her level because they're so sub-margin that it takes the CEO to say, yeah, we can do that. So she saw the actual number for our aggregated business, and we're very healthily profitable, thank you. And oh, by the way, one of the parts of the server business that is growing the most rapidly. Actually taking the IDC data, both the server tracker and the HPC tracker, and all the good work we've done to relate those to one another, looking at our own numbers and looking at the TAM analysis over time, we're basically looking at a forecast that says that the density optimized business, basically the hyperscale business I was talking about, is on a path to become something on the order of half of the overall HP server business in not a lot of years. And that's with the other parts of the server business not necessarily shrinking. That's really our growth, not their shrinkage. That translates into a willingness to invest. Thank you.